Well, good afternoon, everyone. My name is Jean Messier. I'm the Curatorial Projects Manager here at the museum, meaning I'm in charge of creating new exhibits. I was also heavily involved in the writing of all the interpretive panels you see out in the galleries. And during that process, the rest of the curatorial and writing team, myself, were given a very specific mandate, which was, whenever possible and when appropriate, tell Indigenous stories. And indeed, it's impossible to fully tell the story of Canadian aviation, especially of northern bush flying, without talking about the extensive involvement and contributions of Indigenous peoples. After all, it was into their traditional territories that the first bush pilots and those that they carried, trappers, prospectors, missionaries, and the like, were venturing. But this contact wasn't just one way. Yes, aviation brought technologies and services and products that were not previously available, job opportunities, access to medicine, communication, different types of food, things like that. But also, early bush pilots, and indeed bush pilots to this day, depended heavily upon traditional Indigenous knowledge and technologies to make their jobs easier. And for a good example of this, we can look at the Hudson Strait expedition. So this was launched in 1927 by the federal government to survey ice and weather conditions over Hudson Strait between northern Quebec and Baffin Island. And this is part of a much larger endeavor to determine the feasibility of building a deepwater port at Churchill on Hudson Bay. Now, the pilots involved in this expedition were originally issued with standard World War I era British cold weather flying gear. But the vast majority quickly swapped these out for traditional Inuit clothing like anoraks, mukluks, mittens, and the like, because they found them to be a lot less bulky and a lot warmer. And as a further testament to how much they relied on Indigenous technology, as standard emergency equipment, you could say, every flight over the strait carried an Inuit hunter. And it was his job, if the aircraft came down over the strait or over the tundra, to help the crew survive and guide them safely back to base. And of course, there are several other Indigenous technologies that are in common use by Westerners venturing into the interior and the north of Canada. For example, snow blindness goggles, snowshoes, dog sleds, kayaks, and canoes. And canoes especially have proven very useful to all sorts of people, like I said, trappers and prospectors, etc. And their use persisted well into the era of aviation and into the present day. So much so that it was actually very common to carry canoes aboard aircraft. So, for example, say you're a trapper going to check your trap lines, or you're a prospector looking to stake a claim, you would hire a bush pilot, he would tie your canoe to the aircraft, he would land on a lake, let you go off and do your thing. You would come back at a prearranged time, rendezvous with the pilot, put the canoe back on the aircraft, and fly out. And this became such a common practice that in 1935, the National Research Council carried out a series of wind tunnel tests to determine what is the most aerodynamically efficient way of carrying a canoe aboard an aircraft. And they came up with a number of different configurations. The best in this chart were found to be number 8, number 10, and number 11. And they passed these on to bush pilots, who proceeded to completely ignore them. Because as it turns out, the most aerodynamically efficient ways of carrying a canoe aboard an aircraft are also the least convenient to carry out in the field. So imagine you're in a bush plane that's floating on pontoons beside a dock. How on earth are you going to lash that canoe to the bottom of the fuselage? So what most bush pilots ended up doing was what they'd been doing all along, which was to bring the canoe up beside the pontoon, throw ropes underneath it, pull it up onto the pontoon, and lash it in place. And funnily enough, according to the NRC, this was the single least efficient way of tying a canoe to an aircraft, but it was the easiest to accomplish in the field, and that's what the bush pilots went with. Now, there's another form of Indigenous technology that was very useful to Westerners that we really wouldn't think of as technology, and that is cartography, map making. Now, one of the more interesting items that we found and decided to interpret in the museum galleries was this. This is a hand-drawn map of the waterways connecting Cumberland House in Saskatchewan with Split Lake in Manitoba. And this was drawn by a Cree trapper named Cheche and a Hudson's Bay cartographer named Peter Fiddler in 1806. And I can show you here the actual pathway that this describes. Now, at first glance, just looking at this map, it would seem to be, rather unsophisticated, rather crude, rather, well, to use a very loaded term, very primitive. After all, it doesn't actually show the true shapes of the lakes and the rivers. It doesn't show them in true geographical relation to one another. It's just a bunch of blobs connected by lines. And because of this, you would think that a more modern map, such as those created through aerial photography, or in the case of this Google map here, through satellite imagery, would be, more sophisticated, more useful, just a better map overall. But I would argue otherwise. I would argue that if you really look at it, the Cheche and Peter Fiddler map is a lot more sophisticated than it looks, and is actually brilliantly suited to purpose because it is highly optimized for the type of transportation it is intended to be used for. So let me explain. So the Cheche map is intended for use by somebody traveling by canoe. And the thing about traveling by canoe is you're not traveling over land a whole lot. You are constrained to the lakes and rivers. Indeed, that's the whole point. Other than a handful of portages, say there's an obstacle like rapids or something like that you can't traverse by canoe, you're really not venturing outside of the waterway. So why do you really need to know what's outside? Number two, if you're constrained to the surface of the lakes and rivers, you really can't see the shape of those lakes and rivers. So why do you actually need to know that either? So when you think about it, you only need a handful of things to actually travel effectively by canoe. You need to know what lakes there are along your route, in which order they appear, what rivers or channels connect them. You need to know the location of your starting point and your end point, your destination, and you need to know whether there are any hazards along the way. Like I said, rapids, portage points, and things like that. And if there are multiple channels coming out of any particular lake, you need to know landmarks, say a particular tree or rock outcropping or something like that, to allow you to choose the correct channel. That's it. You really don't need any other information. And this is exactly what the Cheche map gives us. No more, no less. I would argue that there would probably be one extra piece of information that would be useful in a map like this, and that would be approximate travel time between different points. So say if you're planning a multi-day journey, you'd want to know, okay, I should set up camp once I pass this lake because the sun is going to be setting. But other than that, this gives you exactly the information you need with no distractions. Now, the situation changes if you change the mode of transportation. So aircraft are generally unbound by geographical features like lakes and rivers. Now, if I can take a little bit of sidebar, sometimes they actually are. So if you read the accounts of early bush pilots, they talk about a practice known as steamboating, which was when the weather was very bad, if they had low cloud or fog, or if they were in a snowstorm, they would actually drop down to tree level and follow the lakes and rivers to their destination as if they were traveling by canoe. But for the most part, aircraft are unbound geographically and can travel as the crow flies. You can just point your aircraft towards a specific compass heading and fly straight there. And so the type of map you need for this type of travel changes. You need a map that shows the true geographical relation between all these different destinations fixed to a north-south longitude-latitude grid. You need to show the actual shape of all the geographic landmarks below you and a bunch of other information to allow you to navigate. So you can see this map right here shows beacons and airports and other details, anything a pilot would need in order to navigate. The point is that neither map is more sophisticated or primitive than the other. They are both simply optimized for a particular mode of transportation, and they give you only the information you absolutely need to use that mode of transportation, no more, no less. Now, something you're probably wondering at this point is, why do you need to represent the true shapes of geographical landmarks like lakes and rivers on an aviation chart? Is it not just enough to show the location of the different settlements so you can set your compass heading and go towards it? What we have to understand is that in the early days of bush flying, pilots really didn't have a lot of sophisticated navigation aids. Yes, they had compasses, but the farther north you go, the closer you go to the North Magnetic Pole, the more declination you have to compensate for on your compass, the less accurate the compass becomes. There's also deposits of magnetic ore in the soil that can also deflect your compass, and a lot of these aircraft were built of steel tubing, and the compass was added almost as an afterthought in the middle of all the steel tubing without any compensation. So you really couldn't trust your compass. And more sophisticated navigation aids, radio navigation aids, gyro compasses, and things like that either came much later or were too unreliable in the harsh conditions of northern bush flying to really be useful. So in most cases, pilots, if they had clear visibility, would navigate using landmarks. They would have strip maps that were prepared using aerial photography, and they would consult those and say, oh yeah, well, I recognize that lake, it's got a certain shape, then we must be here, let's go to the next lake that we recognize, and so on and so forth. So they were still using visual conditions in order to navigate. Now, when I started writing about the CCPYT map and trying to interpret it, something occurred to me. I had a bit of an interesting revelation, which was that the map was very similar to a more modern type of map for a similarly restrictive form of transport that, unlike the CCPYT map, is widely celebrated as a classic of efficient communication and effective graphic design. So let me show you what I mean. So this is a map of central London. Those of you visiting from Ontario, you know which London. And this is a road map. So this is the type of map you would use if you're traveling by car, by taxi, or by bus. It shows all the streets with their different intersections. It shows all of the different landmarks. But anybody who's spent any amount of time in London knows that the best way to travel around the city is not above ground, but below it, using the famous London Underground network, aka the Tube. And this is the Tube network as it is today, overlaid over a regular map of the city. And what you'll notice is that this is fiendishly complicated. These tube lines run in very complicated shapes. They overlap one another. They run parallel, under or above each other. This is extremely complicated to interpret, especially if you're a commuter trying to use the system to get from point A to point B. But strangely enough, that's exactly the type of map that early users of the Tube had to contend with. This is a Tube map from 1908. The system wasn't nearly as extensive as it is today, but as you can see, this is still really, really difficult to interpret. And it was only going to get more complicated as the system expanded. But in 1931, an employee of the Underground Network, a gentleman named Harry Beck, had a bit of a revelation. What he realized was this type of map gives you way too much information that you actually don't need. For example, do you really need to know where all the streets are and where they intersect? You're underground. You can't see them. You can't see any landmarks. You can't see what direction you're going in. Why do you need to know this? Also, why do you need to know the shape of all of these different underground lines? After all, you can't change the direction that the train is going. It is constrained to a solid tube underground. So what is it that you actually need to navigate by tube? And you're probably figuring out by now where I'm going with this. Well, Harry Beck figured that you only needed 4 things. You need to know which stations there were and in what order they appeared on the network. You need to know your starting point and your destination station, which station was closest to the landmark you wanted to get to. You need to know your interchange stations, which stations allowed you to change from one line to another. and you needed to know which direction you're going in. That's it. That's all a map needs to communicate. And based on these principles, he came up with the world-famous London Underground map. And you can see what he's done here. All of the lines, just as before, are color-coded for ease of identification. But what he's done is he's completely changed the geometry of the map. The shapes of all of these tube lines no longer represent their actual geographic shapes because, again, you can't change this. There's no need to know these. They're laid out here just for graphical simplicity, to allow the whole map to be more easily read. The interchange stations, as you can see, are very clearly marked with different symbols, so you know exactly where you need to get on and get off and where you can change stations. And the problem of deciding which direction you're going in is solved by naming the two different directions of each line by the terminus stations, the stations at one end of the line and the other. You only have two choices, and it's very easy to figure out what direction you're going in. So this gives you all the information you need to travel by tube. And like I said, you've probably figured out where I'm going with this. This is almost identical to the logic of the Che-Che-Pee-Wee-Tee map. Just like the London Underground, traveling by canoe is a very restrictive, very linear form of transport, and so the logic behind navigating these two systems is almost identical. And this was released in 1933, and this became an instant hit and has become regarded as a design classic. And the modern tube map is nearly identical with a couple of refinements. You can see that since 1933, the system has expanded significantly, but the principle is the same. And pretty much every subway network around the world, whether it's Montreal and Toronto or New York, Athens, etc., uses this same basic graphic layout. So to conclude, I think this presents a very strong case for why we need to go back and reevaluate Indigenous modes of thinking and Indigenous technology. Because after all, the logic used by Che-Che-Pee-Wee-Tee in creating his canoe route map was identical to that used by Harry Beck 130 years later for his tube map, yet one is completely forgotten today, while the other is considered an enduring classic of communication and graphic design. And it really goes to show that it doesn't matter who you are, it doesn't matter where you're living in the world, it doesn't matter in which time period you're living, good, effective communication is good, effective communication. Good ideas are good ideas. Intelligent thinkers are intelligent thinkers. Whether you're traveling by canoe across Canada in 1806 or traveling by tube across London in 2022. Thank you very much.